So this webinar will introduce key tools and best practices for unifying design disciplines using SolidWorks. At first, we are going to quickly go through an introduction of me, your host for today's webinar. Then we will have a look at the overview of integrated design processes. And after that, I will give you an example application of how the process looks like in the development cycle. We will also discover the best practices for this approach with the use of SolidWorks and the integrated 3D Experience PLM platform. And lastly, I will wrap up the webinar with a brief summary before we move on to a short Q&A session, for which you can already start posting questions through the Q&A tab on Teams. But before we dive into the topic itself, a brief introduction of me. My name is Akseli Hyväri, and I work at TECHNIA as a sales executive. Although I don't have a mechanical engineering background, I work closely with teams across multiple disciplines and industries, helping them leverage SolidWorks and 3D Experience to improve their design workflows and collaboration. However, I have recently started diving into the practice of mechanical design as well, and I have to say that although learning a new skill from scratch is never easy, using SolidWorks has made it quite fun. And now on to the first section, giving you an overview of a unified design flow. When designing a product, many companies still use disconnected tools for mechanical, electrical, and software engineering. This disjointed approach can lead to errors, delays, and miscommunication between teams. The need for integration is clear here. A unified environment enables simultaneous work on different parts of a product, ensuring that everything fits together right from the start. Disconnected workflow suffers from numerous disadvantages related to siloed teams, which creates issues regarding incoherent communication and slow design cycles as iterations put the design flow all the way back to the start. In connected workflow, the teams are united, which clearly enhances the communication paths and unites the design cycles. In a disconnected workflow, the next stint of development can only start when the previous design work has finished, but in the connected workflow, different departments can work on the project simultaneously. And this is demonstrated as road signs here. Instead of traveling the total of 1,000 kilometers as separate legs, they can be positioned on top of each other, greatly reducing the time to travel the total distance. And to tackle the challenges of disconnected product development, SolidWorks provides a fully integrated design platform. Whether you are working on mechanical parts, electrical schematics, or embedded software, all of these elements come together in one shared environment. The integration isn't just about working in the same tool, but about breaking down silos so teams can work more collaboratively and efficiently. In the past, this environment has played out totally under the SolidWorks ecosystem, but in recent years, Dassault Systems has expanded the collaboration and data management model to cater growing PLM needs. This means that today, the solutions are under one platform that expands even much farther than engineering teams. Before, all the SolidWorks tools were separate software, which were integrated only between each other, meaning that the data was mainly usable for engineers. However, today, the tools have been upgraded to serve the growing need of omni-channel approach inside and outside of organizations. It's not sufficient anymore for only the engineers to have the recent data, as many other departments would benefit from the use of it as well. Therefore, the statement of single source of truth is concrete for all stakeholders, but more about this topic later. Here are some of the key benefits of integrating software, electrical, and mechanical engineering in SolidWorks. Firstly, improved collaboration between different teams, which might, for instance, enhance the room for innovation. Reduced errors due to real-time data sharing, which diminishes the risk for overlapping work or rework. Accelerated time to market with streamlined workflows, which can be vital in the face of disruptive market conditions so that you get to the market faster than your competition. Increased product quality through enhanced validation and simulation tools, simply resulting in better products. And lastly, reduced overall design costs due to faster cycles and fewer defects, improving profitability. And to give you some concreteness around the topic, this section demonstrates the use of integrated product flow through an example design process. So now let's look at how collaboration happens between different disciplines. First, in a traditional product data management or PDM environment, and then in a product lifecycle management or PLM environment. Capable PLM platforms like 3D Experience can be considered an omni-channel platform as it allows designers to work from anywhere, anytime, and any way they want, always being connected to the most recent data. In a traditional PDM workflow, each engineering discipline typically works in silos, and the mechanical design usually starts first because the rough mechanical bodies need to be in place for the electrical team to begin their work. Mechanical engineers create 3D models and assemblies determining things like physical dimensions, locations for mounting points, and clearances. And once these preliminary models are complete, the electrical designers start drafting their own work, creating first schematics and wirings. The work of electrical engineers is done with reference to the mechanical model, ensuring that the design fits within the available space. Then the iteration cycles continue, mechanical designers receiving the first versions of electrical teams' intended eCAD models, which can already perhaps be used to plan the possible contacting points or wiring routes, and likewise the electrical team having to adjust to the limitations or possibilities that mechanical engineers have meanwhile defined. Lastly, often mechanical designers are left to do the final routing between connectors and electrical components before the final version is set to be validated. However, this PDM approach leaves software designers out of the loop, meaning that they cannot simulate control system, define interfaces, or develop software against virtual prototypes. Only afterwards, the software engineers can step in. They often need to wait until the hardware design is mature, since they require information about the system's physical interfaces and capabilities, and they have no way of getting truthful information before first physical prototypes, leading to inefficiencies and slow iterations. But now let's move to a PLM-driven approach using solutions like 3D Experience platform. The key difference here is that all disciplines, mechanical, electrical, and software, and even more if there is a need, are working in a unified digital environment from the start, enabling simultaneous collaboration within the same model-based system. For example, mechanical engineers can start by creating the first 3D mockups, and electrical engineers can begin placing components right away, even as the mechanical design evolves. All changes are instantly visible to everyone, ensuring that electrical and mechanical components fit together from the very beginning. Software engineers too can work in parallel by testing and simulating how their control systems will interact with the hardware, thanks to the seamless integration of virtual twins and real-time data. And the best part is that these tools are easily adopted by anyone. SolidWorks is a tool that everyone knows. electrical schematic designer is based on SolidWorks electrical schematic professional, and the connected software engineer PLM role is used by software designer to manage source code and build artifacts in a multidiscipline product structure for traceability and governance. This PLM-driven collaboration brings several benefits. First, it reduces delays caused by dependencies between teams. Since everyone has access to the same live data, changes made by one discipline are automatically reflected across all teams, speeding up the iteration process. It also improves accuracy and reduces errors, as there is no need for back and forth communication to update models or designs. But most importantly, it enables a much more agile development process where teams can continuously optimize their designs without having to start from scratch. And this leads to faster time to market, higher product quality, and the ability to handle complexity in a much more efficient way. So while PDM can help manage files and revisions, PLM enables true multidisciplinary collaboration, unlocking the full potential of the omni-channel concept. So let's look at an example of how integrated design works in practice. Imagine a team developing an electric bike, a product with mechanical components, electronics, and embedded software. In an integrated environment like SolidWorks and 3D Experience, the mechanical designers can develop the housing, the electrical engineers can design schematics and wiring, and the software team can embed the necessary code for functionality, all within a unified platform that's constantly synced up to date for everyone. On the right, in the 3D Experience add-in view, you can see that non-synced status of the top 5 entries is clearly visible for the mechanical designer after they have edited the associated parts on their SolidWorks desktop view. All the mechanical designer needs to do is to save the changes that he made, and then the version updates are for everyone to see on the 3D Experience platform. Likewise, the mechanical designer receives prompts on his interface if the part that they are working on is not the latest, someone having made changes to it. And if the designer is the owner of the part and has the right credentials to do it, they can lock the part state seen on the very right side of the view, so no one can make further changes. Then, if a different version of the design wants to be made from the locked version, designers can create a new revision based on the original part, and the traceability throughout the life cycle is then ensured. On this demo, we have a customized dashboard that consists of the key disciplines that a smart device would have during its life cycle, all in one cohesive environment. So let's play the video. On the welcome page, we have a product structure explorer that lets the user scroll through the bill of materials. The CAD format shows what's the native software used to create the part or an assembly, and you can quickly open it in the preferred CAD like SolidWorks 3D CAD or the cloud-based SolidWorks 3D Creator. The Collaborations tab displays the community page where all stakeholders can contribute by posting updates, ideas, or just general information. And Document Management and Specifications tab lets the user view and manage all the documents connected to the product, whether they are product specifications, market analysis, or user manuals, for example. Relations tab shows the relationships that surround the product, which can be both hierarchical or one being tied to multiple other elements. Component search and reuse has widgets to scroll through the online catalogs of parts from third parties ready to be used in your design. Here, companies can also import their own internal part catalogs. eCAD tab has the BOM displayed on the left side while showing the visual location of the part on the right. The parts are highlighted by clicking either the BOM or the 3D model. And here, users can generate issues or change actions by creating a clear annotation linked to a specific part of the 3D model. The issues can then be delegated based on the given information and severity as seen here. On this demo, the ModSim page has only videos, but in an actual case, this tab could be embedded with simulation tools, allowing for a simultaneous modeling and simulation of the design, hence the ModSim name. Likewise, the next tab could be used as a collective page to gather all the results received from the simulations. And now, with 3D experience, bringing software development into the mix is easier than ever before. The software developer can track different branches and iterations of software. For example, the developer can check the requirements for each task, and below they can access the software development connector to create new code or make changes while also keeping the source code up to date on this platform. On the Release tab, viewers and users can track the maturity state on both hardware and software levels. And lastly, manufacturing item structure shows manufacturing bill of materials of the product, and the MBOM can be directly defined, managed, and updated from the 3D design coming from SOLIDWORKS. Below, the manufacturing engineer can analyze and manage manufacturing processes and communicate it to the organization, perhaps by adding instructions for execution on the shop floor. And it's important to note that all of these are not visible for the usual engineer, as they want to only see the tools that they need to do their job. Therefore, everyone can customize the platform's interface to their own liking. So now we are going to go through the best practices for a unified design process. So let's demonstrate how 3 key pillars, communication, continuous testing, and data management work together to ensure seamless collaboration and efficiency across teams. So first, communication is key. In any successful product development process, communication needs to start early and happen continuously throughout the project. It's essential for mechanical, electrical, and software teams to be aligned right from the beginning, especially during the conceptual and prototyping phases. By sharing information openly, we can avoid misalignments, and later in the process that might cause delays or rework. With tools like SolidWorks and 3D Experience, communication flows across departments in real time, creating a shared environment where everyone is on the same page. This collaborative foundation helps ensure that the design is cohesive from day one. Next, continuous testing and validation. Once the communication flow is established, it's vital to validate designs continuously throughout the development cycle. With an integrated design environment, mechanical and electrical systems can be simulated and tested in real time alongside the design process itself. SolidWorks and 3D Experience allows us to run simulations at every stage, whether it's mechanical stress analysis or, for example, an electrical currency test. So this real-time feedback helps identify potential issues early before physical prototypes are built, saving both time and cost while improving product quality. And finally, data management and version control. As the design evolves, managing design data and version control becomes critical. Having everyone work on the latest revision or version of a design is essential to avoid conflicts and rework. 3D experience ensures that every team member, from engineers to project managers, has access to the most up-to-date design data. Version control systems also provide traceability, so you can easily see who made changes, when they were made, and ensure that no configurations are lost. This structured approach to data management keeps the entire process running smoothly and ensures that teams can collaborate without the risk of outdated information. To wrap things up before the Q&A session, let's go through the main takeaways from this webinar. So it's rather evident that integration isn't just a buzzword, it's essential for modern product development. To summarize, 3 key points could be lifted onto a pedestal. First, unified collaboration across disciplines. SolidWorks and 3D experience enable mechanical, electrical, and software teams to work together in one connected environment. And this breaks down silos and improves communication, helping teams collaborate more effectively. Second, real-time data synchronization for everyone. The integrated platform ensures that any design changes are visible to everyone in real time. This reduces errors, accelerates iterations, and helps eliminate delays caused by outdated information, ensuring that everyone is always on the same page. And finally, agile development from start to finish with PLM. With PLM-driven workflows, you can achieve faster time to market and higher product quality. The continuous optimization of designs allows teams to respond quickly to changes and stay ahead of the competition. So all in all, by adopting this unified approach, you will streamline your design process, improve collaboration, and boost overall efficiency. So it's a wrap. Thank you for attending today. I hope you found today's session helpful and will join our next webinars as well in the upcoming weeks. The next one will be hosted by me as well, and it will cover some expected return on investment calculations regarding SolidWorks and 3D experience licenses. If you are interested in learning more about the solutions, feel free to reach out to me or my colleagues. And next, we will have a brief Q&A session, but for those who are already in a hurry, have a great rest of your day.